So today we're going to do our lab 1 of our learning guide 4, which is insulators and conductors. So what we're going to do is we're going to click on the link that's included in this lesson. Then when we come to this screen here, it's going to give us a choice, introduction or lab. So we're going to click on lab a couple times, and then it's going to open up to our screen. So what we're going to do now is we're going to build a circuit. So if we were in the shop, we'd actually grab all the parts out of the bins and make it. But since we're here, we can't do that. Or virtually. So what we're going to do is we're going to grab a battery. And all you're doing is just grabbing it from the side and dragging it on. I like to make everything nice and clean so I can see it better. So then I'm going to grab a piece of wire. And I could just stretch the wire all over, but I like to make my circuit so that it's, like I said, nice and clean. I can see where everything's at. So when we have a circuit, circuits are made up of insulators and conductors. An insulator is the plastic or something that electrons can't get through, and a conductor is something that electrons can get through. So what I'm doing here is I'm building this very simplistic circuit. And I'm going to put some stuff in there to see if it's an insulator or conductor. So I have a light bulb here. I know that a light bulb's a conductor, unless it's broken. But, you can see how I just kind of pivot it by grabbing this little circle here. Now the circles, as you saw when I put this together, are the conductor, the attaching points. So you can see that attached right there, and then I'm going to slide this up to this circle, and when I let it go, my electrons are flowing. So we know from past lessons that electrons flow from negative to positive. The bottom of this battery is our anode, and anodes are negative. So I know the bottom is negative because anode begins with A, and S, which would be your bottom, begins with A. And that's how I remember. So you guys can remember any way you want, but A for the anode, A for the anode is on the bottom, and cathode, which is the top part, or the positive part. So the electrons come out of our anode, they go through, you can see they go through the light, and when they go through the light, it produces a brightness. That's what light bulbs do. And then it goes back into the positive side, and it creates this loop. Now this is a simple circuit. Now if I wanted to take this out and replace it with something else, I would then click on here, and you can see scissors show up. I click the scissors, and it cuts it. Click here, boom. I can take my light bulb over here. I can just hit the delete button. No, I can't. Oh, there it goes. And if I highlight it, I'm sorry, and then you hit the trash can, it goes away. So what we're going to need for this circuit is conductors and insulators. So we have a resistor here. I'm going to put a resistor in there. Now, you guys don't know what a resistor is, but a resistor is part of a circuit. We use them. We're going to be using them a lot. So I have a resistor. I'm putting a resistor in my circuit. I'm pulling this down. And yes, a resistor is a conductor. The electron, I can see the electrons moving. So that means it's a conductor. If we were building this in real life, we would not be able to see the electrons moving, of course. But in this situation, we can see the electrons moving. So I'm going to take this out now. I'm going to cut it out. Highlight it and throw it away. Boom. Now there's an arrow over here. Click the arrow and it's going to come to some other stuff. So we have a fuse. And we'll talk about the fuse a little bit later. But for now, there's a fuse, another light bulb, another resistor. It looks different. We're going to click that down arrow again. Now we're going to come to some interesting stuff. We're going to come to a dollar bill. Now, as you guys know, dollar bills are made out of paper. Paper, if it's wet, is a conductor because the electrons flow through the water, but if a paper is totally dry, we will see, and the electrons do not flow. Everything's connected, and the electrons aren't flowing. What you should do is also, you see how I'm stretching this back and forth, and you can see that it's pulling on the wires. That means that shows you that it's connected. And also this little spot turns gray when it's connected. So I can honestly say that a dollar is not a conductor. It's an insulator. Now, let me grab this paper clip. I'm going to pull that out. And wow, the electrons are flowing so fast through that paper clip that it literally melted the paper clip and caught the battery on fire. So I'm going to click on that and take that out of there. So I'm going to say definitely a paper clip is a conductor. Now I want you guys to go through, and on your sheet you're going to see some stuff. We got a pencil, a dog, a hand, a wire. Of course we know what a wire is. An eraser and a coin. And I'm also going to ask you the paper clip and the dollar bill again. So I want you to use the sheet that you got this link off of. And then what we're going to do is you're going to pull it up, a dollar bill, conductor or insulator, paper clip, conductor or insulator. And why? Well, when I cooked the paper clip or the dollar bill in there, the electrons did not move. So that told me it was a insulator. Put the paper clip in there. Everything burst into flames. That told me that it was a conductor. So, any questions? Now, we got one way to keep things from bursting into flames. Maybe you might want to try this too. So, if we put a light bulb in here, in class, we'd put a light bulb in here. So, if we put a light bulb right here, and we connected these wires, and something's not working. I think that's a bad light bulb. Let's not use that light bulb. Let's go back up here and use this light bulb. There you go. I don't know what to do with that light bulb was. All right, so we got this light bulb in our circuit, and it lights up. So if I cut this right here, now the light bulb's going to be a load. We learned about loads in the first or second chapter. I can't remember now. But the light bulb's going to act as a load. So if I put the dollar bill in there again, the light bulb does not light up. And I know it's hooked in because the wires are moving. And I'm going to cut out that dollar bill. So if we were in class, we'd be making something like this. We'd put a light bulb in there because we can't see the electrons flow. And then we're going to grab a paper clip, and we'd be doing this in real life in class. And we put that on there, and you can see that the electrons, instead of bursting in the circuit, instead of bursting into flames, the light bulb is sucking up some of those electrons, and the light bulb's lighting. So if the light bulb lights, we have a conductor, and if the light bulb does not light, we have an insulator. So what I want you guys to do is grab some wire, and I want you to put your first initial in wires on the side here. And my first initial is, you know what? Do both initials. So my first name is Davis, so there's a very bad looking D. And of course my last name is Haynes, so I'm going to make an H. And it's a very awful looking H, but it works. And then I'm going to go down, when you're all done, or while you're doing it, I want you to go down here and you see these three dots. Click on them, and it's going to say, make a screenshot. I want you to make a screenshot, and I want you to save this to your computer, and I want you to attach it. So I'm going to change the name to Haynes Circuit Screenshot Lab 1, because that's what it is. And I'm going to save it to my computer, and then I want you to attach it to this assignment so that I can see you made it. So again, what I did was I went down here to these three dots, or it's that whole logo. Click on screenshot, and then that thing came up and I could save it. But I want you to put your initials on there so I know you did it. And then turn it in. And like I said, there's going to be all these things on there. Just figure it out and set it up. The light bulb lights, continuity. This is called a continuity tester, actually. A battery and a wire and a light bulb is called a continuity tester. So that's what we're doing. Continuity means that it's a conductor. And we know that our paperclip is and our dollar bill isn't. So if you have any questions, talk to the real Mr. Haynes in class. And if not, good luck on this lesson.